Good evening, ladies and gentlemen. Thank you very much for giving me a voice. I will today talk about pretreatment of uh, pine wood into hemicellulose ethers by pilot scale production. The work was made by Professor Christopher Collet from New Zealand University of Rotorua, and this work is titled Pilot Scale Production of Hemicellulose Ethers from Softwood Hemicellulose Obtained Compression Screw Facade of Thermo-Mechanical Pumping Plant. And this work was published in Polymers, volume 15 this year. And this work says that hemicellulose is part of lignocellulose, which contains building in cell walls, and this is used mostly obtained as xylene, which and GGM in both cases in hardwood and softwood. Since in the wood waste more is used pine tree, the bigger trouble appears. Therefore, we need to more about production from this case, and the molecular waste is quite high, from 16,000 to 24,000. So, of hemicellulose of oxacetylgalactoglucoman, especially. This is the longest in case of pine, and this shows us the trouble that is many mass give much possible, but are much crystal, and this needs to be broken to form ethers. This method can be used as good plastic alternative. So this can epoxy functional epithels, polypropylene oxide production, and crystal ether. And this shows us that bleach can be isolated, and more good point is the pretreatment. First, the pressate was from freshly pine from a sawmill was produced in the after preheater of pilot scale and stored in the 4 degrees Celsius. Then the preheating was made by 160 Celsius and 20 minutes. So this is partly shell drying case, and this isolation was made of hemicellulose fraction was made by after drying we get 600 kilo per assay was filtered nylon mesh pore size to remove fines and then treated with special resin from Taiwan, XAD7, which contains xylase and enzymes, and then resin was washed and removed nylon cloth for removing the salts what's happen, and then go to the sodium hydroxide washing and purified by ultrafiltration and retention twice, by membrane special, and this was acylation was to produce cellulose, and then additional bricks permit flow was increased. The retentate was at adding soft water, and second nest was flowing of quite high flow rate of this way, this mixed way, soft watering retentate, 0.6 liter minutes, and then after first day and the second day and in the second day increase happen to 6 liter per minute. This shows that restriction in modification of the final retentate was through by different membranes and then frozen. And then next was the sample measured at ultravisual spectrometer. The acid insoluble was measured by us in lignin standards, similar that we make drying and building, and this was cutting. And then we get analyze freeze dried. And therefore, we have synthesis and purification of 3-butoxy 2-hydroxy populated hemicells. And retentate 345 kilos and sodium hydroxide, giving the solution final concentration. And that gives the finally, after purification, polypropylene block, which can be used as polymer. And discussion was polypropylene obtained from polysaccharides, non-hemicellulosic. This is good information because it allows for polypropylene prepared in the matter that is quite from renewable water, which is pine tree, but give much energy. So needs some addition of some renewable energy source and heating, for example, by solar or wind, or by heating by gas, for renewable biogas, for example, for getting renewable being green coal, because maybe the process takes pine as source of polymer, but this is quite much energy, so needs this energy be taken from and redesigned to produce more green way and more feasible way. Therefore, this work is interesting in point of hemicellulose. So if you compare, but it will make a trouble with case of energy source of such pilot scale. Thank you very much for listening to me.